Hello everyone, this is another video from Easy Electric series, and in this video we are going to learn about another new advanced parameter in VFD, which is A090 motor overload current select. So what it really means. So for explaining that, maybe these three graphs that you see actually help us to understand what really means. So let's see. First of all, for A090, you have three options. You could select on the zero, which says it's no D rate. You could choose that one, it means minimum D rate, and then if you choose two, it says actually maximum D rate. Let's see what's no D rate means. So if you take a look to this graph, in one side it shows the percentage of the motor overload current. So which is usually we give from parameter P33, and the x-axis is percentage of P32, which is a motor nameplate maximum frequency that we adjust in early in these series of the video. So which we learned that we call that as a max frequency that you could reach. So that means here, let's say y-axis is somehow is your overload current, and the y-axis is the frequency. Whenever you have no derated, so that means whatever you adjust on P33, the motor overload current. So no matter your motor run in which frequency, that's actually exactly the same thing that you adjusted in P33. But whenever you put that on minimum D rate, somehow you have something like this. So that means it's telling in some frequency, which is more low frequency, less than 25 hertz. So that number is not actually if the right number. Technically, some percentage of that is your new motor overload current. But after in higher frequency or after 25 hertz, you still the motor overload current is the same number that you have on P33. Somehow you try to decrease that in lower frequency. So maximum D rate is the same thing, but this time this is more actually sharp slope. So that means in a low frequency, maybe under 50 hertz, you actually decrease number of the motor overload current that you give on P33 by some percentage, depending on the frequency. And after 50 hertz, that number is right, and motor overload current is that number that you see. So what it really means, it means whenever you do this for a low frequency, it looks you actually make that more sensitive to the fault, right? Especially on the lower frequency, you decrease that number. So if it goes over that, you actually get there or so. But in no D-Ray, technically, that's actually whatever you put here is actually is a right motor overload current. So if you take a look to the bigger picture of that, it looks in lower frequencies, it looks it's try to somehow decrease the motor overload current. So the reason of that could be because whenever motor is started, so that means in low frequency, usually it takes a lot of the current. So this somehow you actually limit that with somehow you protect the motor, and somehow it's uh, it's actually is related to the protection. So the other thing that actually here is important to know is overheat. So technically these overheat happen in the low frequency because you actually have a huge torque, you have a load, you want to turn that, and you slowly in the slow frequency, usually the motor takes a lot of the energy. So that means overheat happening that time more often. The other thing is a fan. The fan that you have usually attached to the shaft. So that means whenever your motor shaft is turned slowly in low frequency, technically the air fan also is it work more slowly. So that means it's another factors that it's actually make that more sensitive in lower frequency, and with doing this somehow you protect the motor from overheat too. So if you take a look to this slide that I make, somehow I summarize more important part of that. So as I mentioned, the first things that you need to know it is the question is why low frequency require derating. So the one factors that you need to consider, as I mentioned, is a motor cooling fan is on the shaft, and technically the fan speed follow the motor speed. So lower frequency, low speed for the fan, and technically you have less airflow and technically less heat removal from your motor. So that means with using the A090, somehow derating that. So technically, you try to change the motor thermal overload curve, and technically you reduce the allowable overload current and the low speed. Somehow you protect that from overheating, because as we know, low speed plus the high torque, it usually actually give you the highest overheating risk for your motor. So if you take a look to that option that you have in A090, which is motor overload selection, so no derate, it is actually the lowest protection. It allows the higher or the highest overload, and it's very slow trip. So the minimum D rate is a normal protection. Standard motors default is usually on that. And the maximum D rate is a highest protection, and it's trip faster on overload. And the reason is you decrease somehow that overload current, especially in the lower frequency that you have. So I hope you like this video. Thank you for watching.